Couple weeks in our 8th grade physical science class, we've been looking at Newton's 3 laws and simple machines. And there's a lot of vocabulary words in these two chapters. So my goal was to make sure that our students not only understood the words themselves, how to spell them, how to define them, but also how to use them in real life. The standards that we were focused on, cross-cutting concepts were scale, proportion, and quantity. Practices were planning and carrying out investigations, analyzing data, using mathematics and computational thinking. And the core ideas were that the motion of an object is determined by the sum of the forces acting on it. The total force on the object is not zero, its motion will change. The materials we used, in addition to our textbook and quizzes, we used some Quizlet for vocabulary review, as well as YouTube videos to help the students better understand the concepts, and lab materials for creating simple machines and measuring the forces and distances acting on those. To start out with, we tried to get the students interested in understanding these 3 laws. Those are kind of simple in the sense that the students have known about gravity for many years, but there's a few misconceptions that I wanted to address. We did move through that chapter fairly quickly. We did a lot of activities in class where the students acted out centrifugal forces, where they acted out different forces and how they affected acceleration. We used a basketball. We used YouTube videos to help the students understand those issues. We spend more time on the 3rd chapter, the simple machines. We started out with just an introduction from the text and a YouTube video showing the different types of simple machines. And then we showed a Rube Goldberg machine that some 7th graders had created, and I asked the students to actually verbally identify the different machines as we went through that Rube Goldberg process. After that, we went through and learned about friction. We learned about rolling, static, and fluid friction, and the students did some research projects and writing projects on what new technological inventions like Hyperloop rely on reduced friction, and understanding why so much investment is going into this worldwide, as everything from swimsuit designers to soccer ball designers try to reduce fluid friction and make their equipment work more effectively. The next thing that we did was we looked at work, power, joules, and watts, and did some calculations with that in class as well as out of class, and from the textbook. And then we asked the students to actually do some problems with input force, input work, input distance, output distance, where they were doing the calculations in class on the board, as well as using their outside of class using the text. Our last step of our process is what you saw in the video that I showed today, and that was where we wanted to see the students if they could actually make 6 different simple machines and complex machines, and if they could measure the input force, the input distance, the output force, the output distance, the efficiency, mechanical advantage, and create a lab report describing those things. And what I found is the students really understood the 6 machines. They understood the terms related to them. They understood how to spell them. They had done some practice on Quizlet, so that had helped reinforce those concepts as well, I think. So from our top student to our lowest student, they had those basics down. But where they struggled was in how to design a machine which they would actually then measure the input force and the output force on. So while they understood the input force concept theoretically, when it came to actually taking a pulley and figuring out where they would hook the Newton scale and how they would pull it to measure the input force, none of them really could do that initially. And I didn't teach them it explicitly because I wanted to see if they could develop it themselves. And they really didn't. So they went through the thought process of trying to figure out how to do it. And in the end, I did show them how to find the input force and the output force, and help them do those calculations. So going forward, that's one thing that I would like to look into more is as we look at next generation science standards and we look at trying to teach the students the engineering process and to use inquiry-based learning to more deeply reinforce these concepts. I need to evaluate the pros and cons of how much time do I give the students to explore when something is not easy for them to do, before I step in and say, okay, now this is how we do it. This is how we do calculate the forces and efficiencies, etc. In the end, they did all understand. They are working on their lab reports, and I'll look over those tomorrow. But just from looking around in class at the things that they were working on today, I can see that they understood the terms, they understood how to use the terms, how to do the measurements on their devices, how to do the calculations. And so each of them have reached the standards that we set out to in this lesson.